Okay, let's get started with products liability. All right, so what is this? This is a specific area of law that deals with the legal responsibility that a manufacturer, so a producer, an assembler, a distributor, anyone who is creating a product, has for any injuries or damages caused by those products. So the point is to really ensure that manufacturers create safe products, right? That they disclose risks, that they properly label items so that we are, at the end of the day, protecting consumers. This is about quality control, creating incentives to maintain high standards of safety and quality in the products that they're making. So if you put a product out into the market and it hurts people, and there's reason to that you should have known it was going to hurt someone, or you did something, you did something negligent, that caused it to hurt someone, you're going to be held responsible for that. The rules about it are very different than the negligent rules that we've seen, and it really places way more responsibility on the manufacturer. I'm going to use the word manufacturer here, on the manufacturer of the product, because they have more power than the consumer does. They have more knowledge about the product than the consumer does. They're in the position to protect the consumer. And so we put a lot more responsibility on the manufacturer. Product liability can extend to any type of product. So consumer goods, vehicles count in that, electronics and appliances, to pharmaceuticals, medical devices, machinery, food products. So any products that you're putting into the market for purchase gets covered by this product's liability. And so here's the big thing. This is what makes it so different from negligence, is that products liability is generally considered strict liability. That is the highest form of liability that we have in law. And what that means is we don't need to prove intent. We don't need to prove you were negligent. You can try your best. It does not matter if you did everything right and your product still hurt somebody for one of the reasons that we're about to talk about. It's strict liability. It doesn't matter what your intent was. It doesn't matter if you were being reasonable. It doesn't matter if you went above and beyond. If your product caused harm for the reasons, if they meet the elements we're about to discuss, intent doesn't matter. And that really alleviates a burden on the consumer who's hurt to have to prove what the company was thinking or how hard the company tried. They don't have to prove the company was negligent. They only have to prove that they were injured. So let's take a look at what product liability entails. So there's really three types of product liability. I'm going to move my screen up a little bit so you can see. The first is called is manufacturing defect. There is a defect in your manufacturing. So the product does not meet your own specifications. So your design was good, your specs were good, but something happened in the manufacturing process where your product fell below your own standards and they were sent out within a substandard manner and it hurt someone. We'll go into a little more detail about manufacturing defects, but let's talk about the other two. The other one is a design defect. So this is a little different than manufacturing. This is why we have the picture at the bottom. But the design defect means that the design of the product was defective. You designed it poorly. You manufactured it exactly according to specs. Everything went out. You intended it to be what it is, and it still hurt someone because the design was poor. So I have this picture, this graphic underneath my face to kind of explain the difference in the two. So if you are a manufacturer of a fan, the first fan, in the first picture, we see a fan there and something's wrong with it, right? Like the base of it is broken, it's got wires exposed to it, and now the fan blade is tilted. Something happened. There's a deviation from the specifications, right? That's the defect. That is a manufacturing defect. If someone gets hurt because of that, they would sue under the theory that there is a manufacturing defect. Now look at the second picture. We have a fan. It's not broken. It looks like that's the way it's designed. That fan in the middle looks exactly the same as the other fans. There's like not enough spokes. I can stick my finger in it. That's a design defect. So that's the difference in between a design defect and a manufacturing defect. And the third one is a warning defect. The products don't include the appropriate warnings. So let's break these down a little more and see, go into more detail. So again, I don't want to repeat myself too much, but a manufacturing defect is when the product doesn't meet the manufacturer's own specifications. So maybe the design is perfect, it's fantastic, but something happened during the creation, during the manufacture of the product that made it not operate, the way that you intended it to. So manufacturing defects can really be split into two different types. First, maybe the manufacturer constructed the product from some kind of flawed raw material. So, say like unduly brittle steel was used in a wheel, and that wheel cracks, right? So this is a raw material issue. The other way that we get manufacturing defects is when the manufacturer assembles good raw materials, but in an erroneous manner. So for example, they accidentally, sever an important cable, electrical cable during the manufacturing process, and so the product doesn't work well, or it electrocutes you. So in either case, the product did not meet the manufacturer's own design specification. If a plaintiff can prove this, if they can prove a manufacturing defect by showing it doesn't meet specs, then there's not really much the manufacturer can do. If it doesn't meet your own specs, it's kind of open and shut case, right? Because your specs are your specs, and you really can't defend yourself if the product is shown that it doesn't meet the standards that you had. Um, so unless like a particular AV technology relies on a part that's prone to defectiveness, like say that's a sensor with a high rate of defect, I don't really anticipate a lot of manufacturing defects in automated vehicles, but you never know. You can be surprised. There's always you're less likely to. I think you're less likely to see it in like a software situation, but I can imagine situations like with hardware where something's not properly installed and it leaves it's really going to have to be some kind of like a hardware issue. So, for example, if a sensor or a camera in the vehicle is improperly installed during production, and it leads to a failure to detect an obstacle that causes an accident, I can see a manufacturing defect in that situation, but they tend to be a little more rare because there's quality control checks around the vehicle. So these do happen. I'm not going to say they don't happen, but the next one is one I think is going to be more of an issue in AVs. So design defect. The design of the product is unreasonably defective. So an allegation of a design defect says that the product is the product itself is defective. It came out exactly. We didn't have an issue with a sensor being nothing was improperly installed. No poor raw materials were used. Everything came out the way you intended to, and that is what caused the accident. So, in the automotive context, you usually see this brought up in the case where they say a vehicle is not crashworthy, that the way they designed it, for example, doesn't protect passengers in cases of rollovers or something like that. But as vehicles, get better at avoiding crashes rather than focusing on crashworthiness and surviving them, we might think of crashworthiness in a different way. Courts have really looked at two principles when it comes to design defects. Actually, before I get to those two types, I want to give an example of a design defect in the AV sense. So, if the software is programmed in a way that misinterprets road conditions, like a sharp curve, and there's an increased risk of collisions, this would be a design defect, right? Because your algorithm, as you put it out, doesn't detect this properly, so it's a design defect. So the two ways that courts really look at whether or not there's a design defect. The first is, consumer expectations. Is this product more dangerous than a reasonable consumer would expect it to be? If it's more dangerous than a reasonable consumer expects, there's a design defect. And this can really come up in the AV world if your customers, if a reasonable consumer expects your vehicle technology to be safer than it actually is. If for some reason they expect it to be safer than it actually is, and their expectations aren't met, leading to to an accident, you might be at fault for a design defect. So, you know, this is still the reasonable consumer test is in use in some jurisdictions, but it's a little too subjective. It's a little unworkable. So a lot of jurisdictions, really have sort of abandoned that use, but it's still relevant in a lot of states. So the other test that judges will use is the cost benefit, also called risk utility. So is the defect worth the risk? So, if this AV software is misinterpreting, road conditions, but the software is really, good in other respects, and it's very safe in other respects, and in 9 times out of 10 it's correct, and it was either put this software out or don't use the software at all. You might argue that it's worth it to put this software out. So if the way this software is programmed, if you changed it and it would make it more dangerous, you could argue that, like, yeah, this isn't the best, but we did it this way to avoid this thing that was much worse. And so the risk, yes, there is a risk here, but it's worth it for the other benefit that we might get. I'll give you a little bit better concrete example of this. So here's what happened. Let's have a hypothetical situation so we can look at this cost benefit or risk. You more commonly hear it called risk utility. The risk of the design is worth it for the utility of the design. That's where that comes from. Okay, so here's what happens. There's going to be a lot of text here, but I think it's important that you get the details. Okay, so apologies, I autonomous rolls off the tongue. So the autonomous vehicle manufacturer designs its software to prioritize collision avoidance over strict adherence to traffic signals, right? So sometimes when these two things are going to be at odds, we're prioritizing avoiding a collision. So the AV is programmed to run a red light if its sensors detect that stopping is going to cause a rear end collision or other type of accident. So if it needs to if it knows that the car behind it is traveling, really closely, it's going at a speed where it can't possibly stop. Say it's reading the face of the driver in the other vehicle. It's not an automated vehicle and the driver's not paying attention. The AV concludes that it's better for me to just go ahead and run this red light because I know for sure the person behind me is going to rear end me. So say that happens and the AV crashes into a pedestrian crossing the street. All right, that's our setup. That's our accident. So here's what the pedestrian's going to say. This is a design flaw. You designed that vehicle to run a red light, and I got injured. Plaintiff's going to argue, the plaintiff is the injured person, that the AV should have been designed to follow traffic signals, right? And if you had designed your car to follow the law, I wouldn't have gotten hurt. And so, strict liability, you have a design flaw, you trained your car to break the law, I was hurt, strict liability, I am owed compensation. The risk utility would allow the manufacturer to come back with a defense. So under this test, the manufacturer would say, yes, we did train our vehicles and program them to run red lights, but overall we're trying to maximize safety and minimize harm. The benefits of this design, fewer severe accidents, lower overall fatalities, outweighed the risk associated with this really rare situation of there just happened to be a pedestrian this time. 9 times out of 10, when the car makes this decision, there's no pedestrian and a crash is avoided. So the manufacturer could also say that a safer alternative design, I wouldn't say safer, I would say an alternative design, such as one that never overrides traffic, was considered but specifically rejected because it was deemed more dangerous. So yes, we did look at that design that the pedestrian is saying we should have adopted, and we did not adopt it because this one actually was deemed safer. And maybe they'll show models, and maybe they'll show statistics, right? To show that this design is defective, it did run a red light, and it did hit the pedestrian. But the risk was worth the utility. The cost is worth the bigger benefit of 9 times out of 10 avoiding an accident with no pedestrian injury. And so the outcome really depends on the judge, on the jury. So if the court accepts the manufacturer's argument, then the design is not defective and the plaintiff cannot recover, right? Even if there was an alternative design that would have avoided the entire injury, we're not going to find that the vehicle is defective, right? So this is a reasonableness argument, right? We can't avoid every single accident. So this design is not defective. Again, this is going to be incredibly subjective, and the judge or the jury, probably the jury, is going to have to decide, what's the overall safety atmosphere, what are the specific risks, and we're going to determine what the trade-off was, right? So this is very, very, very intensive balancing act. So we talked about manufacturing defects, design defects. The third type of product liability for which a manufacturer can be liable is a warning defect, right? The product does not include appropriate warnings. So you put something out there and it's dangerous or it has risks. You can mitigate that by putting on warnings, right? So an example of this, if an AV struggles with identifying pedestrians in certain lighting conditions, and the manufacturer does not warn the operator of the vehicle that that's the case, that is a failure to warn. That's a warning defect, right? And now if that AV hits that pedestrian in that lighting, we have a warning defect, a product liability issue. If you issue a warning and you let the operator know that, hey, at dusk, we can't see pedestrians, you need to pay closer attention. You need to turn the automated driving off if you're in a high pedestrian area. Now you have mitigated that risk, right? There's no failure to warn in that situation. It's going to be interesting how the duty to warn changes with automated vehicles and just more modern connected vehicles in general. Because the manufacturer, used to it, put the car out and that was it, right? They get feedback based on what the car was doing, based on, drivers taking their vehicles into dealers, and maybe eventually the manufacturer puts out a recall, right? If they get notified of enough issues with a vehicle. But let's go back to the data, with the sheer amount of data that the vehicles are collecting and possibly sharing with the automaker might be hyper aware of every single issue, and there might be an increased duty to warn, right? So that the automaker knows more, and with the communication with the vehicle, the manufacturer actually has an easier time giving these warnings, right? We have over-the-air updates. We have infotainment screens, right, that the automaker can control. So the duty, it's much easier to warn, there's more ways to warn, and the automaker has more knowledge of which, to warn about. So it'll be interesting to see how warning, defects changes with the introduction of automated vehicles and connected vehicles in general. On that note, I want to take it back to manufacturing and design defects, and how AVs might be affected by the current liability regime. So, we're still working on perfecting automated technology, right? And maybe it's not perfect, but it can be pretty good. But the way that our system of liability is set up currently, it might actually disincentivize deploying this technology until it's 100% perfect in some ways, right? We're talking on a mass scale, not in like the testing phase that we are now. So let's just imagine a scenario where, we have automatic braking, crash avoidance technology. And this is already out there, but let's imagine it's not, and let's take it back in time. So say this automatic braking works 80% of the time, right? In 80% of the time, if the human driver does not brake when they need to, the car will go ahead and auto brake. But 20% of the time, it doesn't work. The technology just isn't good. Victims who are hit because the vehicle failed to brake properly might be able to sue the manufacturer and allege either a manufacturing defect, like the product doesn't meet the manufacturer specs, right? It's supposed to break and it doesn't break, or a design defect, like the way you designed it, it's not functioning correctly. And they might have a claim. But if the auto braking feature reduces accidents by 80%, I mean, even if it's wrong 20% of the time, that's better. Yet the manufacturer is opening itself up to liability by even putting this feature on the market if it's not exactly perfect, right? So we let the perfect be the enemy of the good in this situation. And so this is an example of how our current liability regime doesn't really, best support the deployment of automated vehicles in this sense. So just wanted to bring that up. So this concludes products liability. Let's take a look at some of the other theories of liability under which the manufacturer could be held accountable.